Hi everyone! If you want to be exceptional at differentiating logarithmic functions, there are 15 must-know questions that I'm going to share with you today. By the end of the video, you should be able to differentiate an expression like this with respect to x. So here's the first question. This is an extremely basic one. The important thing is to get the flow right. So to find the derivative of y equals to ln x, first look at the expression after the ln, which is an x. Differentiate this expression, which gives us a value of 1. Place them at the numerator as shown, and divide it by the original expression, which is x. Let's try out another question, number 2, to get the flow right. Zoom in to the expression after the ln, which is 4x. Differentiate this 4x, which gives us a value of 4, and place it over 4x, the original expression that comes after the ln. By simplifying further, we will then have 1 over x. So let's move on to question number 3. Y is equals to half ln 3x. So let's put dy dx to indicate that we are differentiating y with respect to x. If you see a coefficient, which is a half in this case, in front of the ln, simply write down half first, and then differentiate the expression after the ln, which is 3, divided it by the original expression, which is 3x. Simplifying further, we will then have 1 over 2x. Now, if you have more than one term in an expression, not to worry, the principles are the same. In this case, let's differentiate 4x minus 5 first to give us a value of 4, and always put the original expression at the denominator, which is 4x minus 5. And there you have it. This is the derivative of ln 4x minus 5. Now let's move on to question number 5 to explore a slightly different expression. There's y equals to ln 3x squared minus 2. And again, remember the flow. Differentiate the expression first, which is 6x, and place it at the numerator. Write the denominator as the original expression, which is 3x squared minus 2. So this is the derivative of y equals to ln 3x squared minus 2. Now what if you have an expression like this, where there's 2x minus 1 to the power of 4? Not to worry, instead of using the chain rule, there's a special property in the logarithmic function that you can bring down this power 4. And we will then have 4 ln 2x minus 1. Alright, after we have 4 ln 2x minus 1, what we can do is to differentiate this with respect to x by looking at the expression again. First, we can keep 4 at the numerator, differentiate the expression to give us 2, and place it at the numerator over 2x minus 1, which is the original expression. We can then simplify this further to give us 8 over 2x minus 1. I hope this is easy for you. We're going to do another one to solidify your understanding. So look at question number 7. Y is equals to ln 3x plus 10 power 7. Remember, don't get intimidated or overwhelmed. We can bring down 7 to the front. So y is equals to 7 ln 3x plus 10. dy over dx will then be equals to 7. Multiply the derivative of 3x plus 10, which is 3, over the original expression, 3x plus 10. And this will be equals to 21 over 3x plus 10. It is that straightforward and easy. Right, let's take a look at question number 8 right now. Y is equals to ln x plus 1 multiplied by 3x plus 2. Usually, the majority of the students will expand this two expression and differentiate them term by term. But what we can do is a faster technique where we can separate this ln into two terms. So y is equals to ln x plus 1 plus ln 3x plus 2. Now this came from the product law of the logarithmic functions that you see on the screen right now. You can actually refer to this in the separate video linked in the description box below. Right? So to differentiate this, we can do it term by term. We start off with writing dy over dx is equals to Remember, differentiate the expression first, which gives us a value of 1, and place the original expression as the denominator, which is x plus 1, plus 3 over 3x plus 2. Now let's make things slightly more complicated in question number 9, where we have y equals to ln 2x plus 1 power 5, 3x minus 1. Definitely, it is too tedious to expand this expression and differentiate the terms one by one. So we are going to make use of the previous technique to help us differentiate this really quickly. Let's use the product law of the logarithms to help us separate this into two terms. We will then have ln 2x plus 1 power 5 plus ln 3x minus 1. Remember, in the earlier example, we can bring down 5. So let's put 5 in front, and then we will have ln 2x plus 1 plus ln 3x minus 1. We can then differentiate this with respect to x really easily by writing dy over dx, put the 5 at the numerator, differentiate 2x plus 1, which gives us 2, and divide it by the original expression, which is 2x plus 1. For the next term, we are going to differentiate 3x minus 1 first, so we will then have 3 over 3x minus 1. Alright, simplifying, we will then have 10 over 2x plus 1 plus 3 over 3x minus 1. Now, some students are really confused in question number 10. Not to worry, this is exactly the same principle as the previous example. Alright, so instead of writing ln square root 3x cubed plus x squared plus x, we are going to write it in a different way, which is equals to ln 3x cubed plus x squared plus x power half. Now, square root is equivalent to a power half. So what we can do next is to bring down half into the front and write down ln 3x cubed plus x squared plus x. So we can then differentiate this easily by writing down dy dx is equals to half. Let's put a half outside, multiplied with 9x squared plus 2x plus 1 over the original expression, which is 3x cubed plus x squared plus x. And by simplifying further, we will then have 9x squared plus 2x plus 1 over 2 multiplied with the original expression. Now for question number 11, we can employ the quotient law of logarithms to help us separate this fraction into two terms. So y will be equals to ln 5x plus 2 minus ln 3x plus 1. By differentiating term by term, we will then have 5 over 5x plus 2 minus 3 over 3x plus 1. Now, sometimes we are not able to separate the ln directly. For example, in question number 12, where there's a quotient of two functions, or rather a fraction involving ln x over 2x. But what we can do now is to use the quotient rule to help us differentiate this with respect to x. So let's start off by writing 2x first by keeping the second part, and differentiate the first part, which is the numerator, to give us 1 over x. In the quotient rule, it is always a minus, so write the minus over here, and keep the first part, which is ln x, differentiate the denominator, which gives us a value of 2. Now take note to put these two terms in separate brackets, so that we won't mistakenly multiply 2 with the x inside over here. Alright, in the quotient rule, we are always going to square the denominator, so 2x will become 4x squared. Simplifying the numerator, we will then have 2 minus 2 ln x over 4x squared. We can factorize out 2 from the numerator, multiplied with 1 minus ln x over 2x squared. Dividing the top and bottom of the fraction by 2, we will then have 1 minus ln x over 2x squared. Now, there are some situations where we need to use the product rule of differentiation to help us find the derivative. So this is a classic example in question number 13. Y is equals to 2x plus 1 multiplied with ln 3x minus 2. Notice that this is a product of two separate functions. Therefore, we use the product rule by first keeping the second part, ln 3x minus 2, and differentiate the first part, which is 2. Now remember to put a square bracket so that we won't mistakenly multiply 2 into 3x minus 2. Alright, so product rule starts with the letter P, so we're going to put a plus sign over here. Keep the first part, which is 2x plus 1, and differentiate the second part, which is 3 over 3x minus 2. Now we couldn't really factorize any common terms, therefore we will just put this expression as 2 ln 3x minus 2 plus 3 2x plus 1 over 3x minus 2. Now question 14 is a slightly more challenging one. Again, the principles are the same. We can separate this ln into two separate terms. What we can do is to put y equals to ln sine 2x plus ln cosine 2x. Differentiating term by term, we will then have 2 cosine 2x over the original function, which is sine 2x, plus minus 2 sine 2x over cosine 2x. We can go one step further to express these two terms into 2 cotangent 2x minus 2 tangent 2x. Factorizing out 2, we will then have 2 cotangent 2x minus tangent 2x. Now recall that cosine over sine will give us a cotangent ratio, and sine over cosine will give us a tangent ratio. Alright, so let's move on to the last question, number 15. Y is equals to ln 4x plus 1 over square root tangent 3x. Now this is a mouthful, but I'm sure you know exactly what to do right now. So we can separate this ln into two terms, which gives us ln 4x plus 1 minus, I'm going to convert the square root into a power half and bring down the half at the same time to the front, which gives us half ln tangent 3x. Now differentiating this expression, we will then have 4 over 4x plus 1 minus half. Let's leave the half outside and differentiate ln tangent 3x to give us 3 secant square 3x over tangent 3x. Let's simplify this further to give us 4 over 4x plus 1 minus 3 over 2. At this point, I'm going to convert tangent 3x into sine 3x over cosine 3x, and I'm going to bring down secant square 3x as cosine square 3x. Simplifying further, we can cancel out similar terms, which is cosine 3x. We will then have 3 over 2 sine 3x cosine 3x. Now many students will stop over here, but if you look closely, you can observe that 2 sine 3x cosine 3x is sine 6x. So there you have it. These are the 15 must-know questions whenever you differentiate ln functions. Now, I do hope you learned something from this video. Do check out the free practice questions and worked answers that are linked in the description box below, and please subscribe to this channel to see more valuable contents coming your way.